Hi, welcome everyone to this video series of LLM applications. In today's video, we will talk about another LLM based application called structured information extraction from the content provided. So in this application, I'll show you if you provide a particular topic name like a person's name or an organization name or a particular event, we'll take that topic and we'll search through Wikipedia and retrieve the content that's relevant for the topic, and then that content will pass on to a large language model through API, a large language model of choices. So in this case, either OpenAI, GPT-4, or Google Gemini or Anthropic Claude, and pass an instruction in the prompt to extract structured information about the events that has happened around that particular topic, and will pass a schema to extract information like the time, the event name, and the relevant details. And then when you pass that information and the LLM replies back with the structured information of a time and event, and we can take that and create a beautiful dashboard of timelines. Then you can go through the dashboard. So I have created an application using HTML, fast HTML, and the tool is actually hosted on Hugging Face Spaces. I'm going to share the link in the description below. So let's look at the tool. So here's a generate a timeline dashboard using AI. You can select a particular model, and then in this case let's say Anthropic Claude, and pass the API key, and then here you can provide a specific timeline, let's say space exploration, and then you can also specify how many events to be extracted from that particular topic, and then generate the timeline. So it's going to generate timeline now. Now you can see it has generated a timeline and created this beautiful dashboard, which contains I think about 20 events around. So it starts with the first living being in orbit by Soviet space program around 1957, and the launch of Sputnik 1 around the time, and then the first human space flight by Yuri Gagarin in 1961, then first moon landing Apollo 11 mission. Interestingly, it talks about India's Chandrayaan program as well. Then China initiates its space flight program, and then talks about the SpaceX program as well. And so you can see, it can create a content given a topic name, a timeline that you can quickly go through and understand the timeline of it. I have created another timeline for MS Dhoni, and you can see it has created a timeline for MS Dhoni also. Dhoni was born in 1981. It makes a first debut for Bihar in 1999, and then inducts into the team at 2004, and then leads India to victory in 2007 T20 World Cup, and then receives Padma Shri. You can see it's a nice timeline it got created from the topic. So you can provide any topic name here, and immediately going to go through Wikipedia, search the relevant content, puts that into context of the prompt, and sends to the large language model and extract this beautiful structured information. Now let me do a code walkthrough to show you how it's actually implemented. So here is a blog that I have written. I'm going to post the link to the blog in the video description. You can go through that as well. Harnessing LLMs for automated timeline generation. The two key libraries we have leveraged here. One is Pydantic to define the schema, to control the response from the LLMs, and LangChain to implement the communication with the different language models. The first, import all important libraries. So Pydantic And then fast HTML, of course, to implement the UI, which of course I'm not going through in this particular video. I'm just only showing the large language implementation part. Then a prompt template to provide the instructions, and then the Pydantic output parser from LangChain to parse the output from the large language model, and then the interface to 3 different models that you can select: OpenAI, Anthropic, and Google Gemini. And then of course we are also going to use Wikipedia to search for the content. The first thing is we'll define the schema using Pydantic. So there are 2 different classes defined. One is event. So the event class will contain information about one specific event from the content with the time and description. It's also a sentiment we are not using right now. Then there's another class, event response, which is nothing but a list of all events. So the number of events that we can return from the large language models. And then of course we'll set up the LLM. We'll first create a parser to parse that output from the LLM, which will be of course written in a JSON format, and this is going to convert back into a Python class. And then we have a prompt template, and we specify the instructions saying extract the time-based information or events from the context and return a list of events with time and description. The context may contain information about people, organization, any other entity. And then we provide a placeholder for the context, which we will first search Wikipedia about the topic, and once we obtain the relevant content, we will pass this in this placeholder. And then the response must follow the following schema strictly: the format instruction, which will be the JSON schema from the Pydantic classes. And then we can also try to get at least number of events which you can pass dynamically while requesting for generating these events. And then we create a prompt template. And then we'll get the relevant model that we have chosen, either OpenAI, Anthropic, or Google Gemini model, and set that. And then we'll first fetch the Wikipedia content. So given a topic name, we'll first go to Wikipedia and return back the content, and then generate a timeline. So define a generate timeline. Given a topic, an LLM is going to run a query on the Wikipedia about the topic, and it returns the Wikipedia content. Then we'll pass that in the prompt to the LLM, and once LLM responds back, we'll parse it back and give it back the response. So we'll invoke the chain now with the context, which is Wikipedia content, the topic name, and the number of events. So once it returns back, we'll get back the results, and we'll convert that into a data frame and sort it by time. It's important that we sort it by time, because the way it might have extracted the content purely based on how the events are mentioned in the context, but we want to visualize in a time series fashion, and then save it to a CSV file. For example, in this case, you can see it has created a CSV file with the timeline and sorted and different events about the space exploration. Then you can take that and create a visualization out of it. And you can take this code and create your own visualization tool, and I'm also given the link to the tool that's already hosted on Hugging Face Spaces. You can leverage that, provide your own API key, and just provide a topic name and search for the timeline. And if you get a beautiful timeline, please paste it or provide that in the comments in the YouTube video. And if you also can enhance this code to kind of upload a PDF document, and then it goes to the PDF document and search to the timeline and creates a timeline dashboard. So thank you for watching this video. This is another implementation of structured information extraction from the content. And in future, we will look at other applications of LLM. Thank you again.